What we have here is a 355, actually, auxiliary air pump. It introduces fresh air into the exhaust manifold in order to completely burn the hydrocarbons, but only during warm-up. This particular pump is no longer available, and in my opinion, it wasn't a very well-designed pump. It has a plastic impeller and a plastic housing, and in this case, the plastics fused together. The original motor was just trying to mix together molten plastic, and it burned out. It's a high-speed, high-torque motor, and it draws a specific amount of amperage. I've tried to put Dorman motors in these things, and they draw too many amps. So it's a very critical threshold motor. We're likely going to rebuild this one for the next one. In any case, it's inside this plastic housing. It has an air filter on it. The air intake
through the filter
is through the filter, of course, and then this is our exit. Now, we rebuilt a lot of mechanical smog pumps, and they always put out 2.5, 3.5, sometimes even 4 PSI. But these auxiliary pumps never put out that much and are barely adequate to do the job as original equipment, let alone when they start wearing out and develop large clearances. We took this thing. Now, by the way, our videos here are designed primarily as proof of function. We're not going through and showing that we had the impeller out, it was on the lathe, we put a piece of sandpaper in it to make sure it didn't wobble, ran it against that, found clearances, fixed melted plastic, and go ahead and turn this thing on for them. Okay, you want to put a pressure tester on it? So, it's almost reaching 2 pounds there. Not too bad, actually, for a auxiliary electric pump. And what kind of amperage is it drawing?
About 8 amps.
About 8 amps. Plug it and load it, see what it does. So there we are, loaded at 11 amps or so. Some of the Dorman motors draw 20 amps, and they set off codes in the machine, so we got to go with the original. In any case, yeah, proof of function, and thank you for watching.